Hello students, today we will learn highest common factor and least common multiple. This is a very important concept of number system. You can see many questions based on these two concepts in many of the exams. Let's have overview of the session. First of all, we will learn how to calculate highest common factor. Then we will practice some remainder questions based on highest common factor. Then we will learn how to calculate least common multiple. Then we will practice some remainder questions based on least common multiple. Then we will learn how to calculate least common multiple and HCF of fractions. Then we will do applications of least common multiple and HCF. Before taking the questions, let us have a smaller example. Let my numbers are 10 and 15. First of all, we will learn HCF by long division method. See, first of all, the meaning of HCF. See, this is F means factor. So I'm writing factors of 10 here. They are 1, 2, 5, 10. In case of 15, they are 1, 3, 5 and 15. These are the factors of 10 and 15. Then I'll take the second word, which is common. It means we are looking for common factors and they are 1 and 5. Then I'm taking the third word, which is highest. So we are interested only in highest common factor, and that is 5 in this case. So what is HCF of 10 and 15? It will be 5. See, in this case 10 and 15, they are smaller numbers and they are only 2. In case of bigger numbers or in case of many of the numbers, we can go by long division method. What is long division method? This is nothing but conventional division. We will take the bigger number inside and the smaller number outside. I mean, we will take the bigger number as dividend and the smaller number as divisor. We will perform the conventional division. I'm writing quotient here and we are getting 5 as the remainder. Now we will perform the division once again. In this case, the old divisor will be the new dividend. 2 will be the quotient. 0 will be the remainder. Whenever you are getting 0 as the remainder, you stop there. The latest divisor will be the HCF. That will be the final HCF of these numbers. So in this case, what will be the HCF of 10 and 15? That is 5. Now, we will learn how to calculate least common multiple. I'm taking the same numbers. There can be two approaches. One is called factorization method. And another thing is called division method. First of all, I'm going by factorization. You write the prime factorization of 10, which is 2 into 5. You will write prime factorization of 15, that is 3 into 5. Now what will be the least common multiple? We will select all the primes and we will take its highest power. In case of 2, what is the highest power of 2? That is 1. What is the highest power of 3? That is also 1. What is the highest power of 5? That is also 1. So what will be the least common multiple? That will be 30 in this case. Now we will go by long division method. Write the numbers here, 10 and 15. Now here we will take a divisor of 10 and 15. I mean, we will take that number which is dividing the maximum number of numbers. So I can write 5 here. We will write quotients here. 2 and 3. Now we'll divide it by 2. Then we will take 3. At the end, we are getting 1 and 1. So we are left with no number which is dividing 1 comma 1 except 1. We will stop here. Then we will take multiplication of these numbers. So what will be the HCF of these numbers? It will be 5 into 2 into 3, that is 30. Now I am taking various examples. That is the very first question. Find HCF of 18 and 120. Again, we will go by long division method. We will write the bigger number inside and the smaller number outside. We will write the quotient here. Now we will write the remainder. Once again, the division thing. The old divisor will be the new dividend. The old divisor will be the new dividend once again. Since we are getting a remainder of 0, we will stop here. Now the latest divisor will be the HCF. So what will be the HCF of 18 and 20? That will be 6. That is the answer in this case. Now the next question. That is HCF of 204, 360 and 120. We will go by the long division method. You can select any of two numbers. I am selecting 120 and 360. Putting 360 inside and taking 120 outside. Performing the conventional division. Since we are getting remainder as 0, so 120 will be the HCF of these two numbers, 120 and 360. So this is the HCF. Now we will perform the division once again. We will take the latest HCF outside and we will take the remaining number inside and will perform the conventional division. Once again, the old divisor will be the new dividend. Once again, the old divisor will be the new dividend. Putting 84 inside. Once again, the division thing. Since we are getting remainder as 0, that's why the latest divisor will be the HCF. So in this case, HCF will be 12. Now see the next question. First of all, we will try to understand the meaning of this question. It says the numbers 2604, 1020 and 4812 when divided by a common number n, remainders are 12. In every case, we are getting a remainder of 12. So, if we subtract 12 from these numbers, we will get remainder as 0. So, what is 2604 minus 12? That is 2592. 1020 minus 12, that is 1008. And the third number will become 4800. So, my question will become, if we divide 2592, 1008 and 4800 by a common number n, we will get remainder as 0. It means n should be a common factor for all these three numbers. And in question, n should be highest. So, we will find HCF of, that is highest common factors of 2592, 1008 and 4800. We will go by long division method since all the numbers are very big. First of all, we will take any two numbers out of these three. I am taking first two numbers, writing bigger number inside and the smaller number outside. We will perform the conventional division. Now the next thing, take the old divisor as new dividend and old remainder as new divisor, and the normal division. Again, we will take old divisor as the new dividend once again we will do now. In this case we are getting 0 as the remainder, so latest divisor will be the HCF. So what will be the HCF? That is 144. Now I'll take the third number, which was 4800. We will find HCF of 4800 and the number 144. Now the normal division, we are getting 48 as the remainder. Once again, the old divisor will become the new dividend. Since we are getting a remainder of 0, so the latest divisor, which was 48, that is the answer in this case. So we have performed division twice. Now the next question. Now we will learn how to calculate least common multiple of these numbers. They are 18, 24, 30, 120 and 54. We will do this concept in two approaches. One is called factorization and another one is called division method. First of all, we will do factorization. We will find prime factorization for every number. Now 18 can be written as 2 raised to power 1 into 3 square. 24 can be written as 2 cube into 3. 30 can be written as 2 into 3 into 5. 120 can be written as 2 cube into 3 into 5, and 54 can be written as 2 into 3 cube. So what will be the least common multiple of these numbers? Write all the primes which are 2 into 3 into 5 in these case, and we will take the highest power. See, in case of 2, we are getting these powers. They are 1, 3, 1, then 3, then 1. We will select the highest one, which is 3 in this case. Then we will take power of 3. They are 2, 1, 1, 1 and 3. So we will select 3 in this case. Then we will take highest power of 5, which you can see is 1. So what will be the least common multiple? That is 2 cube into 3 cube into 5, which is 1080. Okay, now we will find least common multiple by division method. See, in case of division method, we will write all these numbers 18, 24, 30, 120 and 54. Here we will write a divisor which is dividing many of these numbers. As you can see here, 6 we can take, you could take 2 as well as 3. We will write quotients here. Then again we will write a divisor here such that we will take that number which is dividing at least 2 numbers. So we can take 5 here. Again writing the quotients. If in any case a number is not divisible by 5, we will write the number as it is. Now we will write 3 here since 3 is dividing 3 and 9. Since 4 is not divisible by 3, that's why I'm writing 4 as it is. Then I can take 4. Now we will stop here since we are unable to find a number which is dividing at least 2 of the remaining numbers. Now what will be the least common multiple? Least common multiple will be nothing but multiplication of these numbers, and they are 6, 5, 4, 3 and 3. That's why, and this comes out to be 1080. That's why this is the least common multiple of given numbers. Now let us see the next question, a nice question based on least common multiple. First of all, again we will understand the meaning of this question. See, it says 5 bells start tolling at the same time and they toll after 5, 6, 15, 30, 25 seconds respectively. When will they toll together again for the first time? Again, we will understand the meaning of this question. There are 5 bells. Say they are B1, B2, B3, B4 and B5. The first bell is tolling after every 5 seconds. It means after 5 seconds, then after 10 seconds, 5 more seconds I mean, then after 15 seconds and 20 seconds it is tolling. Now similar is the case with B2, but the time here is 6 seconds. So we can see it will toll after every 6 seconds, or we can say it will toll after 6 seconds, then after 12 seconds, then after 18 seconds and so on. In case of B3, time is 15 seconds. So these are the possible cases. Then we will have 30 and so on. Then B5 is given. So we are looking for a time when all the bells are tolling together. You can see this is nothing but 5's multiple. Again, in case of B2, these are 6 multiple, these are 15's multiple, these are 30's multiple and these are 25's multiple. We are looking for a time which will appear in all these cases. It means we are looking for a number which is a multiple of 5, 6, 15, 30 and 25. It means we are looking for a common multiple of these numbers, and the numbers are 5, 6, 15, 30, 25. Since it is asked when will all the bells will toll together again for the first time, it means we are looking for the least common multiple. Now we can go by division method or by factorization. So I'm going by division method. We'll write numbers here. We'll perform the division. Since 6 is not divisible by 5, so I'm writing 6 as it is. Now taking 3 as the divisor. Since we are unable to find a number which is dividing at least 2 numbers, so we will stop here. Now we will take multiplication of these numbers. And these are 5, 3, 2 and 5. That is 150. So after every 150 seconds, bells will toll together. So this is the answer in this case. We could do one more thing. See, we are interested in least common multiple of 5, 6, 15, 30, 25. Since we are interested only in multiples, that's why we can strike out all the factors. See, in case of 30, you can see 5, 6, 15. They all are factors of 30. That's why we can strike it out. So, we can find least common multiple of only 30 and 25, which will be same in this case. That will be 150 only. So, in case of least common multiple, we can neglect all the factors of any of the numbers, and in case of highest common factor, we can neglect the multiple of any of the numbers. Now come to the next question. First of all, we will understand the meaning of this question. It says, find the smallest number which when divided by 12, 15, 18 and 60, let the number be n. Remainder should be 5 always. First of all, we will find a number. Instead of taking this remainder, we will take remainder as 0. It means when n is divided by all these numbers, remainder should be 0. That implies n should be a common multiple of these numbers. Since we are interested only in least number, that's why we will try to find least common multiples of 12, 15, 18 and 60. So we will find least common multiple of 12, 15, 18 and 60. You can go by long division method as well as by prime factorization method. In this question, I am going by prime factorization method. Now 12 can be written as 2 square into 3 raised to power 1. 15 can be written as 3 raised to power 1 into 5 raised to power 1. 18 can be written as 2 raised to power 1 into 3 square. And 60 can be written as 2 square into 3 raised to power 1 into 5 raised to power 1. Now what is least common multiple? It will be all the primes with highest powers. So in case of 2, this is 2. In case of 3, this is 2. And in case of 5, it will be 1. So this is nothing but 4 into 9 into 5, which is 180. So 180 is the least number which is exactly divisible by 12, 15, 18 and 60. But coming back to original question, it says the remainder should be 5 always. 180 is a number which is exactly divisible by these numbers. So if we add 5 to this number, we will get a number which will leave a remainder of 5 when divided by these numbers. So I'm adding 5 to 180, that is 185. So this is the answer in this case, 185. Now come to next question. A very nice question based on least common multiple. Difficult too. So it says find the smallest number which when divided by 9, 15, 18 and 21. Remainders should be 5, 11, 14 and 17. Let that number be n. In previous question, remainders were same. But in this question, all the remainders are different. But you can observe one thing. What is the remainder between the divisor and what is the difference between the divisor and the remainder? That is 4 in this case. Again 4 in this case. 4 in this case. And 4 in the last case. Whenever you are getting this type of question where the difference between the remainder and the divisor is always same, what is the formula to calculate smallest such number? It will be least common multiple of all the divisors minus the difference, which is 4 in this case. So first of all, we will find the divisors, least common multiple of 9, 15, 18 and 21. We can go by prime factorization as well as division method. We can put 3 here. Now, since we are not able to find a number which is dividing at least 2 of the numbers, we will stop here. Then we will take multiplication of these numbers. That will be the LCM. This is 3 into 3 into 5 into 2 into 7. That is 630. So what will be the answer to this question? It will be 630 minus 4. That is 626 seconds. So 626 is the such number which when divided by 9, 15, 18 and 21, remainders will be 5, 11, 14 and 17 respectively. Now this is a formula. How to calculate least common multiple of fractions? It will be least common multiple of the numerator divided by highest common factor of the denominators. Similarly, how to calculate highest common factor? This is highest common factor of the numerator divided by least common multiple of the denominator. Let's have an example. HCF of 15 by 18, 20 by 15 and 25 by 12 will be HCF of the numerators. They are 15, 20 and 25 and LCM of 18, 15 and 12. Now what is HCF of 15, 20, 25? I think you are comfortable now. That will be 5. What will be the least common multiple of 18, 15 and 12? You can go by either of the approaches. It will be 180 in this case. So this will be the answer in this case. Now moving to LCM part. What is least common multiple of these numbers? 15 by 18, 20 by 15 and 25 by 12. This will be least common multiple of numerators, which are 15, 20 and 25 in this case, divided by HCF of the denominators. So what is the least common multiple of 15, 20 and 25? It will be 300 in this case. And what will be the HCF? That is 3. So what is the answer in this case? It will be 100. Now you can see practice questions. There are 4 practice questions. And these are the answers. Thank you so much. Happy learning.